everybody. Yeah. In our last class, we talked about addition of numbers in base 2. So today, we'll be talking about addition of numbers of different base. That is, we are adding two numbers. It might be two numbers, it might be three numbers in different bases. It can be base 3, base 4, base 5, base 6, base 7, base 8, and so on and so forth. Even hexadecimal. But I will still go into hexadecimal once we get there. But right now, we just talk about the addition of numbers of different bases. So we'll just solve some related examples that we really need to understand concerning this number base system. Now, for example, example 1, if we are dealing with, example 1, we are dealing with 3, 4, 6, base 5, plus 1, 8, 3, base 5. So what the logic I just really want us to know, because I think I told us in our last class that whenever you are dealing with addition of numbers in base 2 or any other different bases that we are trying to talk about, the first thing is that whenever you add those numbers together, if it is up to the base, you divide, and if it is more than the base, you also divide, and you write out the remainder as your answer. Now, let's start with this. 6 plus 3 is 9. 9 divided by 5 is 1 remainder 4. So we have 1 remainder 4. So we are writing the remainder, which is 4, and we keep 1. 1 plus 4 is 5. 5 plus 8 is 13. 13 divided by 5, that will be what? 2 remainder 3. You're writing 3, you're keeping 2. 2 plus 3, that's what? 5. 5 plus 1 is 6. 6 divided by 5, what are we going to have? 1 remainder 1. That's 1. Then we keep this, then we drop it in base 5. You will get that. Now let's solve another related example. Example 2. Let's just solve this. Let's say we're having 5, 6, 9, base 7 plus 2, 3, 8, base 7 as well. So 9 plus 8 is 17. 17 divided by 7. 17 divided by 7. How many times will 7 go in 17? It will go 2 times. That's 14. Remainder 3. So we are writing this as 3. The remainder 3. We are keeping 2 here. So 2 plus 6. What are we going to have here? 8. 8 plus 3 is 11. 11 divided by 7. That's 1. Remainder 4. And we're going to write 4. And we keep 1. 1 plus 5 is 6. 6 plus 2 is 8. 8 divided by 7. What are we going to have? 1. Remainder 1. So 1. Remainder 1. Then we drop that. Base 7. Do we get that? So with these two examples, we should be able to solve any question that deals with addition. We can deal with the one of hexadecimal. We can solve question on addition of numbers in hexadecimal, in an octal system, in a trinary system, and so on and so forth. That's that. Now, in today's, I just really have to just talk about the addition of based on what we really talked about. So today, we'll be going to subtractions of numbers in base 2. So now, let's start. Subtraction of numbers in base 2. So, and we have to follow some rules. 1 minus 0 equals to 1. Then 10, 1 minus 1 equals to 0. 10 minus 1 equals to 1. 11 minus 1 equals to 10. 100 minus 1 equals to 11. So those are the rules that we should just follow. Yeah, and I'll teach us 2 methods that these entails. Yeah, or 3 methods. Yeah. So the first question is, let's solve example 1 on the subtraction. So if we're having like 1000 base 2 minus 11 base 2. So what are we going to do? Solution. So we're going to write 1000 base 2 minus 11 base 2. Now, in terms of normal mathematics, we are dealing with say 0 minus 1, we say minus 1. Yeah, but it can also work in that way. We can use minus 1, but we're not going to write minus 1 here. Yeah, it's just like following modular arithmetic, whereby you don't tend to have negative, whereby you reduce your negative to a positive number. But we're not really going into that. So instead of that, we just go back to our normal mathematics way, the way we solve it in terms of borrowing. So we have to just borrow from this, and this one changes to 0. So any number I borrow that is coming to this next number will be the number of the particular base that has been given to me. So here will be 2. So I'll borrow from 2, 2 changes to 1. So here will be 2. I borrow from 2, here changes to 1. Then I borrow here, then here will be 2. So 2 minus what are we going to have here? That's 1. Then 1 minus 1, what are we going to have here? That's 0. Then I'm going to draw 1 base 2. Do we get that? So now let's solve another examples on that. Now, but before I solve another example, we can decide to convert this man to base 10. Convert this man to base 10, then convert them back to base 2. So what does that mean? That is, if I'm having, let us convert 1000 base 2 to base 10. 1 times 2, 2 plus 0, 2, 2 times 2, 4 plus 0, 4, 4 times 2, 8. 8 plus 0, that's 8. So this one entails that this is 8 base 10. So, okay, let us write it here. 8 base 10 minus. Now, for 11 base 2, 1 times 2, 2 plus 1, 3. So, that is 11 base 2 will be what? 3 base 10. So, 8 minus 3, what are we going to have here? We're having 5 base 10. So, we can convert it to base 2 by dividing by 2. So, 2 in 5. So, that's what? 2, remainder what? Remainder 1. 2 into 1, remainder 0. And 2 in 1 is 0, remainder 1. And if we drag it up, what are we going to have here? 1 over base 2. So that is the other method we can use to solve this. So now, let's go into the example. So for example, we're having 1, 0, 1, 1, 0, base 2 minus 1, 0, 0, 1, base 2. So to solve this question, it is just very, very easy. So what I just really want us to do is solution. Write the question 1, 0, 1, 1, 0, base 2 minus 1, 0, 0, 1, base 2. So let's just write it like this, minus 1, 0, 0, 1, base 2. So let's subtract. 0 minus 1 is impossible. So we borrow from this man changes to 0, and whatever number I'm borrowing is in what base? Is in base 2. So that is here will be 2. Then 2 minus 1, what are we going to have here? We have 1. 0 minus 0, we have 0. 1 minus 0, we're having 1. So then I borrow from this one because 0 minus 1 is impossible. So I borrow from this one. This one changes to 0, and here is 2. 2 minus 1, here what we have here? 1, 1, 0, 1, base 2. So then we can also try the other method. That is, you convert this man to base 10, and this man, you also convert them to base 10, then you subtract them from each other, then you convert it back to base 2. So that is that concerning the subtraction of numbers in base 2. So let us go to subtraction of numbers of different base, like the one we did earlier, that we did the addition. So we'll also be using these examples again to solve for the subtraction of numbers of different bases. So let's start. Subtraction of numbers of different bases. So example 1. So we are using the previous example that was given to us. 3, 4, 6 base 5 minus 183 base 5. So 6 minus 3. What's 6 minus 3? That's 3. Because 3 is not up to the base. So what will I write? I'm going to write 3. Do we get that? Yeah. So assuming it is up to the base in the process of subtraction, in the process of subtracting these two numbers, then I have to divide it by the base here. So then 4 minus 8 is impossible. So I borrow from 3, 3 changes to 2. But the number I borrow changes here to 5. So this 5, you add it with this 4. So 5 plus 4 is 9. 9 minus 8, what will you have there? You'll be having what? 1. Then 2 minus 1, what will you have there? You'll be having 1 base 5. Do we get that? So let's do another example on that. So 569 569 minus 238 minus 238 base 7. If you should look at this question, this one is just straightforward because in the process of subtracting everything, it is not up to the base. So 9 minus 8 is just 1, 6 minus 3 is 3, 5 minus 2 is also 3 base 7. But let's try this last example, and that's maybe, for example, we're having 2658 minus 1964. So what are we going to have here? Very simple. 8 minus, okay, for example, what base should we put it? Let's give it a base of 6. Base 6. So 8 minus 4, what are we going to have here? 4. 5 minus 6 is impossible. Here it changes to 5. So the number I borrow here, 6, will be here. So that 6 plus that 5 is 11. 11 minus 6. What am I going to have here? I'll be having 5. 5 minus 9 is impossible. Borrow from 2, it changes to 1. Then here becomes 6. 6 plus 5, 11. 11 minus 9, what will I have here? That's 2. 1 minus 1, that's what? That's 0. So we don't need to impute this 0 there. So we are just going to have them in big 6. So I'll just be giving just 2 assignments on this, and I really want you guys to work on it. Yeah. So, and if there's anyone that really wants the solution to the assignment, just type that on the comment section. So assignment. So if we're having subtract, let's say subtract the following. So number 1, we're having 3692 base 7 minus 1288 base 7. And the second one, let me give us the one of number base. We're having 1101 base 2 minus 1000. I think this one will be very simple. So let us do 1010 base 2. So I really want us to try this and work on this. So if there's anyone that really wants the solution for the assignment, even for the previous one, just drop that on the comment section. Thank you.